everyone and welcome back to PostNetwork Academy. I am Bindeshwar and in today's video I am going to explain support vector machines. That is a very powerful machine learning algorithm, and we will use a simple numerical example so that understanding would be very clear. So without further delay, let's get started. So basically, support vector machine is a supervised machine learning algorithm, and it is used for a classification as well as regression both, but basically it is used for classification, and that is a discriminative model. That means it finds boundaries between two classes. And it is also known as maximum margin classifier. We will see that why it is called maximum margin classifier. And what does it do? It finds optimal hyperplane that separates two classes or more classes. There are techniques to classify more than two classes, and that maximize margin between support vectors and boundary. See that here these are the points, and this is a hyperplane, these are another kind of line, and this is support vector that is situated on hyperplane. So this hyperplane will separate data points of two classes. So this way support vector machine works, and we will see that in more detail. So suppose there are two classes, +1 that is blue and -1 that is red, and here data points. See that here these x1 x2 class is +1, 3 and 3, that means 3 x1 and also x2 is 3. So class is +1. Also 3 and 4. So class is +1, 4, 3, class +1. The same way P5, P6, P7, P8, and this coordinates 1, 1, 2, 1, 1, 2, 2 and 0.5, and classes are all are -1. See that -1 maybe you can say that yes, and +1 may be yes, -1 may be no, this way, and this may be anything. These may be two features, it is x1, x2, and it may be multi-dimensional, but for the sake of simplicity I have taken only two features. So two features, one class, and these 8 data points we will use. We will train a model, and thereafter we will classify an unseen data, so that you will understand. So here suppose that we are guessing a model in which weights are 0, 1 means a vector and bias is -2. See that what classifier you will get. So you will multiply WT with X. So here see that here W is, you can say that column vector, and B is bias. So what boundary will get? This one. So see that I am just showing you. So this is a column vector, so we will get a row vector, that is 0, 1, and you will also x1 and x2. This is also column vector, plus here -2, 0. So after simplifying you will get x2 minus 2 is equal to 0. So x is equal to 2. So that is the planar line that is separating data points. See that I have chosen myself So this may be one of the classifier. X2 is equal to 2 here. X2 is equal to 2. Now that is a decision function that decide which point would be negative side, which one would be positive side, and that is basically x2 minus 2 we have chosen. Through the optimization technique we get the value of w and b, but here I have chosen, and in upcoming videos I will show you how to get these values after training the model. Here what is the rule? If fx that is greater than 0, so that would be plus 1 minus 1. When fx is less than 0, so that would be minus 1 class. Now if you check all the points, so for a plus 1, 2, 3, if you put here, so you will get, you can verify them, and this side would be minus 1, 3 points, and that is a 0. That means it is a support vector. Remember, that is on that point which is on hyperplane, that would be support vector. And all points basically these are correctly classified except the point 1 and 2, and this is exactly on hyperplane. So basically there is a constraint, and basically we solve this constraint and we get the problem. So here there are two lines. If W transpose xi plus b that is greater than 1, so that will belong to plus 1, and if less than 1, that will belong to minus 1, and if you combine both of them, so you will get this one. This same is combined into one equation. Now points on margin that are support vectors. So this point is support vector. Now margin calculation. So distance from point to hyperplane, that would be the distance from point to margin. So here I have calculated from 0.23 to y is equal to 1. Just we have used distance formula from a point to a linear plane. So we will get 1 here, from 1 to minus 1. So we will get the distance 1 again, and here. So margin width, that is 2. Now if we want to classify 2.25 and 2.25, so we have to use that rule. So just we are using, so if we keep here x2 is 2.2 minus this, actually this model we got f for x new x2 minus 2. If it is positive, so that is in plus class. If it is negative, so that is in negative. So here we have got this one. Basically we have chosen that was aligning with the training data, that negative one negative, positive one positive. In future we will see that we can also get some other decision boundaries after optimizing of getting optimal solution. But in this video just I have made for a beginners, and more videos, because not SVM is not an algorithm, This is a family of algorithm. So many videos will come. So for this point we have got plus. So we can say that this will belong to plus class, this side. This is the hyperplane x2 minus 2 and this is above the point this side. So that is positive one, that is negative one. So the new point you can classify or predict, that is positive plus 1 and that is negative minus 1 here. So separating hyperplane simple, we just chose, and this was aligning with data points. So we have chosen that is satisfying. In future we will see that we can optimize, and weight vector, basically we will try to find out weight vector and bias that clearly separate the data points. Margin with two support vectors highlighted, we have highlighted, and SVM constraint ensures all possible outside margin. New point we have correctly classified plus 1. See that here, just I will like to explain again. SVM is not a single algorithm, it is a family of algorithm, and we will see that some more points we will add, and we will see that how algorithm objectives will change and we will get accurate result. So in future we will understand like maximum margin, also kernel for non-linear classification and many more. We will also learn Lagrange optimizer, you can say that optimization algorithm, Kuhn-Tucker, Kuhn-Tucker, so that SVM will get, you can say that more and more advanced, and we will understand more advanced concept. So hope you understand this one. And this is for beginners, as you can say that first video about support vector machine. Hope you understood, and you can support www.postnetwork.co, YouTube channel @PostNetwork Academy handle, Facebook page, LinkedIn page, and GitHub repository. So hope you understood. Thanks for watching the video.